San Francisco's Millennium Tower was supposed to be luxury redefined. 58 stories of glass and steel with condos selling for $2 million to $10 million each. But by 2016, residents noticed something disturbing. Doors wouldn't close, cracks appeared in walls, and marbles rolled across floors on their own. The building was sinking and leaning. Today, the tower has sunk more than 17 inches and tilted over 20 inches at the top. A roughly $100 million fix was supposed to stop it. Instead, during construction, the building briefly sank even faster. So what went wrong? This isn't a story about one mistake. It's about engineering trade-offs, a multi-billion-dollar blame battle, and the uncomfortable question, if everyone followed the rules, why did this building fail? Let's dive in. To understand why Millennium Tower is sinking, you need to understand the foundation decision that set everything in motion. And that decision comes down to two choices: friction piles or bedrock piles. San Francisco sits on unstable ground. Much of the city, including the financial district where Millennium Tower was built, sits on fill. Loose soil, sand, and debris dumped into the bay over decades to create more buildable land. Beneath that fill lies soft clay known as bay mud, which compresses under weight. And beneath that, roughly 200 to 300 feet down, is bedrock. Solid rock that doesn't compress. When you're building a skyscraper on this kind of soil, you have two options. Option 1, drill piles all the way down to bedrock and anchor your building to solid rock. This is expensive, time-consuming, and requires specialized equipment. But it's stable. Your building sits on rock, not compressible soil. Option 2, use friction piles, shorter piles driven into the dense sand layer above bedrock. These piles rely on friction between the pile surface and the surrounding soil to support the building's weight. This is cheaper, faster, and works fine, as long as the soil doesn't compress too much. Millennium Tower's developers chose friction piles. The piles extended roughly 80 to 90 feet into dense sand, stopping well above bedrock. Engineers calculated that the building would settle around 6 inches over time, considered acceptable for this type of foundation. The city approved the design. The engineers signed off. Construction began in 2005 and the tower opened in 2009. This wasn't a mistake, it was a trade-off. Friction piles saved millions of dollars and months of construction time, and in theory, around 6 inches of settlement is manageable. But the building didn't settle 6 inches. It settled more than 17 inches. And it didn't settle evenly, it tilted. So what went wrong? That's where the blame battle begins. There are two competing explanations for why Millennium Tower exceeded expected settlement. The first argument, the foundation design was flawed from the start. Critics claim that friction piles were inadequate for a building this tall and heavy. The tower weighs roughly 130 million pounds, concentrated on a relatively small footprint. Skeptics argue that engineers underestimated how much the soil would compress under this load and that bedrock piles were the only safe choice. The second argument, the building was fine until the Transbay Transit Center construction project started next door. Beginning around 2010, crews built a massive underground transit hub just feet from Millennium Tower. During construction, groundwater was pumped out to keep the excavation site dry. Here's the problem. When you remove groundwater from soil, the soil compacts. And when soil compacts near a building supported by friction piles, those piles lose support. The soil they're relying on for friction literally shrinks around them. Millennium Tower's developers argue that this groundwater pumping accelerated the sinking and caused the tilt. They claim the building was performing as expected until Transbay construction began, and that the Transit Authority should be held responsible. The Transit Authority counters that the building's foundation was always inadequate, and that their construction simply revealed an existing problem. The city approved both projects, leaving everyone pointing fingers at everyone else. The truth is probably somewhere in between. The foundation design had less safety margin than expected, and nearby construction pushed it over the edge. But from a resident's perspective, the cause doesn't matter. Their homes are sinking. At first, residents didn't realize anything was wrong. The initial signs were subtle. A door that used to close smoothly suddenly required force. A crack appeared in a tile floor. A picture frame on the wall seemed slightly off level. These are things that can happen in any building. Minor settling, temperature changes, normal wear. Residents mentioned these issues to building management, who assured them it was normal settling and nothing to worry about. But the problems didn't stop. They multiplied. More cracks appeared. Doors became harder to close. Some residents noticed that if they placed a ball on the floor, it would slowly roll toward one corner. Floors weren't level anymore, And these weren't isolated incidents, they were happening throughout the building. By 2016, the pattern was undeniable. An engineering inspection revealed the shocking truth. The building had sunk more than a foot and was tilting visibly toward the northwest. The lean was over 20 inches at the top. Not catastrophic like the Leaning Tower of Pisa, but enough to cause serious structural concerns and destroy property values. Here's what that means in practice. Millennium Tower didn't just sink straight down like an elevator descending evenly. It sank unevenly, with one side settling faster than the other, creating a tilt. And that tilt is what causes the visible problems. The sloping floors, the misaligned doors, the cracks. If the building had settled 17 inches evenly, residents might never have noticed. But uneven settlement is what turns engineering problems into human disasters. And for residents, this became a financial and emotional nightmare. People had paid $2 million to $10 million for luxury condos in what was marketed as one of San Francisco's most prestigious addresses. Suddenly, their units were reportedly 30% to 50% less valuable, if they could sell them at all. Who wants to buy a condo in a sinking, tilting building? Owners were trapped. They couldn't sell without massive losses. They couldn't ignore the problem because it was getting worse. Some filed lawsuits against the developers, the engineers, the city, anyone who might be held responsible. Others just tried to live with it, hoping for a solution. The pressure for a fix became overwhelming. In 2020, a retrofit plan was approved. Install a series of new piles, ultimately reduced to around 18, drilled roughly 250 feet down to bedrock, bypassing the problematic friction piles entirely. These new piles would be connected to the building's foundation, transferring the load from the failing friction pile system to solid rock. The cost? Roughly $100 million. But here's the challenge. You can't just drill massive holes and install piles next to an occupied 58-story building using traditional methods. Heavy vibration could damage the structure. Loud drilling would be unlivable for residents. And most critically, the work had to be done with extreme precision. Any mistake could make the problem worse. The solution was a perimeter pile upgrade approach. Drill new piles around the building's perimeter, carefully removing soil to install each pile, then connect them to the existing foundation using a network of grade beams and supports. The entire process required real-time monitoring, sensors tracking every millimeter of movement to ensure the building didn't shift unexpectedly. Work began in the late 2000s, and almost immediately, things went wrong. During the pile installation, engineers removed soil to make room for the new foundation elements. This is standard procedure. You can't install new piles without excavating. But removing that soil, even temporarily, reduced the support the friction piles were relying on. The building, already sinking slowly, suddenly accelerated. It sank an additional 2 inches in just a few months, more settlement in weeks than had occurred in the previous year. Residents panicked. The fix was making things worse. Engineers paused the work immediately and went back to the drawing board. The problem wasn't the concept. Bedrock piles would absolutely stabilize the building. The problem was the construction method. Removing soil from around the friction piles destabilized them before the new piles could take over the load. The retrofit was redesigned. Instead of removing soil first, engineers developed a method to install the bedrock piles without significant excavation, using specialized drilling techniques that minimized soil disturbance. Work resumed with extreme caution, constant monitoring, and slower progress. By 2023, the retrofit was largely complete. The new piles were installed and connected to the building, and the results were mixed. The good news, sinking has slowed dramatically from noticeable ongoing settlement to a much slower, near-stable rate. The tilt has also stopped increasing. The building is no longer leaning more than it was. Bad news, the building is still 17 plus inches lower than it should be, and it's still tilted over 20 inches at the top. The retrofit stopped further movement, but it didn't reverse the damage already done. And it never could. You can't unsink a building, you can only stop it from sinking more. Structurally, engineers say the building is safe. The tilt is not severe enough to threaten collapse. The retrofit has stabilized the foundation. Residents can live there without immediate danger. But here's what no engineering fix can solve: reputation. Millennium Tower will forever be known as the sinking, leaning building. Even though it's been stabilized, even though it's safe, the stigma remains. Potential buyers see the headlines and walk away. Property values have recovered somewhat, but they'll likely never reach pre-crisis levels. The developer's reputation is permanently damaged. The tower's brand is ruined. You can fix a foundation, you can't fix a reputation. And this isn't just a San Francisco problem. Millennium Tower's failure highlights a challenge cities around the world are facing: building on soft soil and reclaimed land. Miami builds on limestone and fill. New Orleans sits on Mississippi River sediment. Amsterdam was literally built on marshland. Tokyo, Shanghai, Jakarta, dozens of major cities face similar geological challenges. The fundamental question these cities must answer is the same one San Francisco faced. When building on unstable ground, how much risk is acceptable? Bedrock piles are safer, but they're expensive. Friction piles are cheaper, but they carry more risk. In a competitive real estate market where every $1 million matters, developers and engineers are constantly making these trade-offs. Millennium Tower shows what happens when those trade-offs go wrong, and it raises an uncomfortable question about regulation and accountability. Every decision made on Millennium Tower was approved. The city's building department reviewed and approved the foundation design. Licensed structural engineers signed off on the plans. The construction followed approved specifications. Inspections were conducted throughout the process. Everyone followed the rules. So if everyone followed the rules, why did the building fail? Are the rules insufficient? Should friction piles be banned for tall buildings on soft soil? Should cities require bedrock anchoring regardless of cost? Or is this simply an unavoidable risk of urban construction, where even well-designed buildings can exceed expected performance? There's no easy answer. Tightening regulations would make construction more expensive, potentially pricing middle-class buyers out of cities entirely. But loose regulations create situations like Millennium Tower, where residents pay millions for homes that lose half their value due to foundation problems. The legal battles dragged on for years, with major settlements reached. Developers blamed the Transit Authority. The Transit Authority blamed the developers. Engineers blamed unforeseen soil conditions. The city blamed everyone. And residents, the people who actually live in the building, are stuck dealing with the consequences of decisions made long before they bought their condos. So what do you think? Should cities ban friction piles for tall buildings on soft soil, even if it makes construction more expensive? Who's really responsible when a building sinks? Developers, engineers, the city, or nearby construction projects? And would you ever buy a condo in Millennium Tower now that it's been stabilized? Let us know in the comments. If you're fascinated by engineering failures, the hidden risks of urban construction, and what happens when billion-dollar buildings don't go as planned, hit that like button, share this video, and subscribe for more deep dives into the mega projects that reshape our cities. We'll see you in the next one.